yesterday? What were the various types of motions that we
Yes, ma'am.
studied?
We studied about
I think Emma is having a network problem. Abraham?
Then we studied about oscillatory motion, circular motion, irregular motion, and rotational motion.
Rotatory motion, circular motion, irregular motion. Then you said
Oscillatory motion,
motion and linear
linear
motion.
motion, and circular motion.
Yes, Abraham.
I'm not the lead master.
Yes. Yes, Emma. Okay, good. Now, we also did length and measurement of distance or length. Okay. Now, the system or the standard unit which is used, okay, for measurement is known as the international system or SI standard. The SI standard of length and distance is meter. Okay, meter, that is recognized worldwide, that is recognized everywhere, is meter. To measure bigger length, 10 times, 100 times, and 1000 times of meter is used. Meter measurement is used. To measure a smaller unit, 1/10, 100th, and 1000th part of meter is used. Okay, now, according to the picture, keep a point 0 on the length of the book. Keep your eyes on the second line of the book and see the number. Note it. It will tell you the length of the book. Okay. So this is a measurement. Okay. Using a ruler. Using a ruler, it is a measurement. Okay. Now, note down the correct measurement of the following items in the table. Length of bench, height of wall, length of table. We are skipping this right now. In our day-to-day life, we use various methods for measurement, and we use meter to measure lengths, okay, tailor measurement, and cloth measurement. Okay, to measure something's length, the measure that tailor uses, and the measure which is used to measure the clothes. Okay, meter we use. Therefore, the distance covered by an object is fixed. The same is called motion. Okay, motion equals to distance upon time. Okay, now distance, because it's calculated in meter and time is calculated in second, so it becomes motion of meter upon second. Okay, remember how many meter per second we were doing? Meter per second we were doing when we were doing the previous chapter, right, in maths, because meter is connected with second, okay, because distance upon time, distance is calculated in meter and time in seconds, so we use meter upon second. Okay, SI technique makes meter as the qualifier of distance and standard units of time. Therefore, the standard unit of motion is meter per second. Okay, that is the standard unit of motion. The SI unit of motion is measured in meter per second. Okay, meter per second. Now, fill in the blanks. There are dash centimeters in 1 meter. Yes, how many meters are there How many centimeters are there in 1 meter, Emma? Can you hear me?
Ma'am, can you repeat your voice very low for me? Wait, I'll try to lift.
Okay. I'm saying, Emma,
Yes, ma'am.
how many meter are there? How many centimeter are there in 1 meter?
Ma'am, 100.
Yes, 100. Good. 100
Ma'am,
centimeters,
1,000 meters in 1 kilometer.
1000 meters in 1 kilometer. Why steps are not used as a standard measure of length? Step means our feet. Why do we not measure steps as standard measure of length?
Ma'am, we do not measure steps as standard measure at length is because uh, the steps can be long and they can be small also. Suppose I want to walk at my normal walking speed. I will take larger steps. Thus, the steps, the size of the steps will always be equal at the same time because of because our foot will land till wherever our legs can reach or wherever we want it to land.
Mhm.
Ma'am, and
Yes.
also like each person's legs are different sizes. So like
Yeah.
it is like handspan. You can never really get the right size of a handspan because everybody's hand size is different.
Yes. Yes, Emma. Both of you all are correct. Now, write in increasing order. Write the biggest, then the smaller one, then the one which is smaller, the smallest. Can you do that?
Mm,
Which was the biggest in these
Ma'am,
measurements?
it's millimeters, centimeters, meters, and kilometers.
Yes, Emma. Millimeter, centimeter, meter, and kilometer. Okay, that is right. Now, the next topic that we will see is called force pushing. There are a few words that are used to explain some activities like pulling, pushing, kick, attack, etc. These activities create a difference in the motion or create a difference in the motion of the object. Can we use one or more words to express these activities? Every work described above can be called as pulling or pushing. Can we conclude that to bring things in motion, we can push it or pull it? Okay. We can, when we want to put things in motion or we want to get things moving, we need to push or pull. Okay. Now, the pushing or pulling of an item in science is known as force. Okay. The pushing and pulling of an item is known as force. Assume that a person is standing behind the car. Does his present affect have an effect on the motion of the car or pushing the car, or is it force? No. Okay. When a person is just standing behind a car, it is not affecting the position of the car. No motion, no force is applied. Okay. Can cars start moving in the direction of movement? No, because the person is not doing anything. But when a person starts pushing the car in a particular direction, the car will start moving in that direction, or the car will be in motion because of the force that is applied. Okay, because the force that is applied. Now, the movement of and then the person stops pushing the car, so the movement of the car stops. Take some heavy item like a table or box, push it, making it in motion. Okay, we push some things to make them in motion. Okay, and when we are pushing, the things come in motion is because of the force that we are applying to bring that thing in motion. Okay, now assume that a person is standing behind the car. Okay, we did this. Push a heavy item like table or box to move. Put it in motion. Make your friend pushing it on the other side. Note down the motion of the table. Can you easily stop a person that is pushing table by more force? Okay. If these two people have the same force, this person is pushing from this side and this person is pushing from this side, and he has uh, 20 energy. Okay, and this is also having 20 energy. What will happen? The table will not move. Okay, the table will not move because same energy they are having, the table will not move. But if this person is having 40 energy, so the table will move in this direction. Okay, because he is having more energy, more force. Okay, he's pushing with more force from one side to that side, the table will move. Another good example of it is a game of rope pulling. Okay, where you pull, the rope, and in rope pulling, the team which pulls the harder or which has more force, which pulls with more force, the rope gets to their end and they win. Okay, and they win. So both items pull each other in their direction. Sometimes the rope does not move. The team which pulls more or exerts more pressure will win the game. If two forces are exerted in different directions, then the total force is equal to the difference between both forces. When both teams exert same pressure, then the rope will not move because same pressure, same force. Now we have learned that one force can be bigger or smaller than the other force. Force is measured by its mass. It is necessary to observe the direction and measurement of force. Okay. The unit that is used to measure force, Newton or N, is used. Okay. If the direction of force is changed, effects are also changed. Force changes the state of motion. Okay. State of motion is called from static to motion. Static to motion. First, the thing was in static stage and then it came into motion stage. And effects, if you are pushing from the left side, the thing will move to which side?
Right.
Yes. If you're moving from the right side, the thing will move to which side? Left side. Okay. So that is the effect.
And
Okay.
on the side.
Abraham, I think you're having a network issue. I cannot hear you. I think now it's better. Now, so if we change the direction of force, then the effect is also changed. Okay. Force changes the state of motion. This is also another activity. Take a rubber ball and place it on a flat surface like a table or concrete floor. Now push the ball on the surface. Do you find a motion? Push the ball again. Do you find any change in its motion? This increases or slows down. Now put your palm in front of the moving ball. When the ball touches our palm, remove your hand. Does your palm exert some pressure? Does it have an effect on the speed of the ball? Does it increase or decrease? If you stop the moving ball with your hand, what will happen? See, with our hand, first we get the ball moving. When it's moving, we give it one more tap and get it moving. That increases its speed. That increases its speed. Okay. Why? Because we exerted pressure, force. Second time we exerted more force. So the speed of the ball will be more. In the second case, the ball is moving, you put a hand in front of it and then remove it. What will it do? It will stop or decrease the speed of the ball because you applied force to, you applied pressure to stop, to try to stop the moving thing, right? So it will decrease its speed. This is the effect of pressure or force on an object, on the speed of an object or on the direction.
Now,
Yes.
if it because of kinetic energy, the ball would not stop. The ball would give the kinetic energy to my hand, and my hand may move a little. But if it's like a strong, sturdy wall, the kinetic energy would come back to the ball, and the ball would move further away from my hand.
Yes, Abraham. Absolutely correct. Okay. The ball will move further away from your hand. Okay. Now, think about such positions. For example, a football player exerts pressure on football during penalty kick. Before kick, ball was in rest mode. Therefore, it had zero motion. The exerted force make the ball moving towards goal. Goalkeeper stops the ball or pushes it to save the goal. The goalkeeper exerts force on the moving ball. He stops or redirects the ball. It also stops the goal. If goalkeeper succeeds in stopping the ball, then the motion of ball is zero. This means that the force exerted on an object can change its path. If the pressure exerted by the goalkeeper is in the direction of the motion of the ball, the speed increases. If the pressure exerted by goalkeeper is in the opposite direction, speed decreases. Okay, understood this thing? Okay,
Yes.
read this activity. Done reading?
Yes, ma'am.
Okay. Now tell me, what will happen if we place the scale? Um, if we place the scale on its way of the moving ball,
You see different angles, right?
different angles. What can you explain it a little bit more?
Yes, ma'am. So the bar on the top left, which is having like a V shape, it is a right angle. So because it's 90 degrees and less, it's less than 90 degrees. The bar on the most bottom is straight, so that's a right angle because it's 90 degrees. No, actually, no, that's an obtuse. And the bar on the top right is also obtuse.
Mm-hmm. Okay. Basically, what happens
Ma'am,
is, yes, Abraham,
ma'am, it's like light reflecting.
it's like light reflected. Yes, it is like light reflected. Okay. The ball changes its direction. Okay. The ball changes its direction when you put a scale in its way and it's moving. It will deflect. It will change its direction. That is what happens. Okay. Now, what are the stages of motion? We'll see. The stage of motion is decided in every object by its speed and direction of movement. Static movement is called zero motion stage. Okay, what is the stage? We determine it by the speed and direction of movement. Okay, the first stage, or when the thing is not moving, or static movement, is called zero motion stage. Every object can be static or in motion. Either it will be still or it will be moving.
Ma'am,
Okay. Yes, Abraham.
ma'am, about the ruler diagram, ma'am, they were, one thing was wrong, ma'am. They should have, the- ma'am, the reflections, I think, were not correct.
Okay. You can watch a video about it and see what directions they go in. Or you can try this at home and check out. Okay. Try this activity at home and see. Okay. Now, either an object will be static, means not moving, or it will be in motion, that is, moving. Both are the stages of motion. This means that force will change the state of motion of objects. This is a general experience that some things do not move even by exerting pressure. For example, a heavy box does not move by exerting maximum pressure. In the same way, force has no effect on the weight. Force can change the shape of objects. Okay. Now, force can also change the shape of objects, like when we press a balloon between our hands. Okay, it flattens, and if and a box is very heavy, we are exerting pressure, but it's not moving. Okay, it's not moving. So some things do not move even when we are exerting pressure. Okay, because its weight is more than the pressure that we are exerting. Okay, because the weight of the thing is more than the pressure that we are exerting. That time the thing will not move. Okay. All these activities makes us understand that force can. Now, what can force do? Okay, this is important. Force can make objects static. It can change the speed of moving objects. It can change the direction of moving objects, and it can change the shape of moving objects. Force can do some or all effects on an object. What are the effects of force? These are the effects of Force on an object. Effects of force on an object. Okay. Although force does not show one or more effects, yet none can be shown without exerting force. Okay. If you are not exerting force, then it might be that none of the effects are shown. Okay, if you're not exerting force at all, this means that no objects can move in it or change its direction or shape without force. So you have to apply force to see these effects. Okay? If you're not applying force, then sometimes some things may not come in motion. If you're not applying force, then things might not change its shape. Okay, so force is very important for these things to happen. Understood? Okay. Take the correct option. Force is force can force can move a thing, stop a thing, change the shape of a thing, or all of the above. Yes, Abraham, Emma. What can force do?
What,
Force
ma'am?
can move a thing. Force can change the shape of a thing, and
All of the above. Okay. Force does all of the above.
Yeah, ma'am.
Now, does force change the shape of an object? If
Yes,
so,
ma'am.
give an
so
example. Can you both give an example when force changes the shape of an object?
Um, Ma'am, if thrown hard enough, it can actually uh, sometimes like put dents in walls.
Okay. Abraham, can you give an example of how force can change the shape of an object?
ma'am, suppose I have a dough. Let's say somebody is making rotis. They have this big lump of dough. When I smash my hand into the dough, or I roll it out with a rolling pin, the kinetic energy from the rolling pin is going and it's smoothing the dough out. That's how it changes an object. The imprint of my hand will come on the dough if I smash it.
Yes, Abraham. Those are correct. Yes, that will change the shape of the dough a bit. Okay, good. Now we will stop here. Okay, you have a break. You have a break, and then
Okay,
we'll
ma'am.
start with maths. Tomorrow we will do Monday. We'll do friction. Okay. Okay. Tell me any science test that we can keep next week. Shall I keep the science test to chapter 8 next week? Thursday.
Ma'am, next week we are not keeping a test, I think.
Maths we are not keeping test. Science I think we are keeping.
Ma'am,
Hmm.
ma'am, I may not be able to attempt the tests because next week Mama has kept my NIOS.
Okay. Mama has kept your NIOS. All right. And the quiz will be in class itself, right? Quiz will be in class itself. Okay. So
Yeah, ma'am.
quiz you will be attending the classes, right, Abraham?
Yes, ma'am, I'll be attending the class.
Okay.
So we'll have a quiz inside of class.
Yes, in the class.
And
Next
do we
Friday.
have to like say the answer out loud or write it in our book?
You have to say the answer in the class, okay? I'll mark if it is correct or not.
Okay, ma'am.
Ma'am, can we have a chat quiz? Like each of us opens a chat to you, like personally, and then we can type the answers on that, like
Chat.
for one round.
I'll see Abraham. Okay, I'll see.
Ma'am, suppose I say answer A, then another person who doesn't know the answer will also say answer A because they just want to because they just want to copy the other person's answer. Or suppose Amna says A, I also say A because I heard our answer.
Abraham, you'll only one question, only one person will be given the chance to answer. Okay, it will be like that. Like you, one question I'll ask from you. If you it's correct for you, then it's good. If not, then it's fine. Another question, Emma, I'll ask. Then another Abraham, I'll ask. One question for Abraham, one for Emma. One is this round where each one of you will get one
Okay,
question.
ma'am.
One more round,
So
it'll
we
be like
don't have to type it in the chat. We just have to say it to you.
say it, yeah, say it.
Okay, ma'am.
Okay. Yes, when your turn comes, then only you have to say. Then the second one is a buzzer round. Buzzer round is what you have to raise your hand first. Whoever raises their hand first to answer will answer the question. Will get the chance to answer. Okay.
Okay, ma'am.
Now the thing is here, the click is that the you cannot like
Ma'am, which chapter will it be on?
think which chapter. Can you suggest me which chapter? I'm finding it difficult to think which chapter.
Ma'am, in science, right?
Maths. Emma,
In
maths.
maths?
Hmm.
Um,
I was thinking fraction.
yeah,
Okay.
ma'am, we can do fraction there.
We'll do fractions, I was thinking. Okay.
Um,
So let's do fraction. Abraham, fine. I won't make it very hard. Okay. Not very
Ma'am, can we
hard.
do percentages instead, ma'am?
Can we do percentage?
I don't mind anything.
Okay.
Because like ma'am, I don't think you've taught fractions. Or can we do algebra?
No, not algebra. Okay. Because it requires you solve and say. Okay. I'm wanting something that directly you can mention. Directly, or you can just calculate in your mind without doing a lot of calculations and letting me know. That's what I'm thinking. So fractions, okay, percentage, then it is okay. Percentage, we'll keep a quiz on percentage, and next Friday we'll do in the maths class itself. Okay. 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 Break for y'all now. Break for y'all now, and we'll meet for maths.
Okay, ma'am.
Okay, let's begin. Hi, Jayashwa. Good morning.
Hi, ma'am. Good morning, ma'am.
Good morning. Abraham, Emma, videos on, please. Abraham and Emma.
I'm back. I'll just like turn on my camera in a bit. I'm just finishing doing something.
So, today we will practice some questions on simple interest. Okay, simple interest. Yesterday I told you what is interest. Okay, interest is of two types. Interest is of two types. One is called simple interest, and the other one is called compound interest. Compound interest. Okay. Today I will teach you simple interest. Simple interest. Okay, we know three main things are there. Okay, three main things are there. What are they? What are they? Principal, rate, and time. Okay, principal, rate, and time. These three things are used to calculate simple interest. Okay, these three things are used to calculate simple interest. Okay, which gives us the formula. Simple interest is equals to P into R into T upon 100. Okay, principal is denoted as P, rate is denoted as R, and time is T. Okay, PRT upon 100, PRT upon 100. Multiply all the three and divide it by 100. Okay, this is how we calculate simple interest. Okay, now what is compound interest? Compound interest is a different thing. Okay, is a different thing in which interest is calculated on the principal plus interest of the previous year. Okay, see, simple interest I'm calculating. Simple interest I'm calculating. The same interest will be for first year also. I have to pay the same. Second year also. Third year also. Okay, but compound interest, I calculate first on. I calculate first the first year's interest and then add it to the principal of the first year. Okay, and then calculate the interest of the second year on that whole thing. Okay, so it gets compounded. It gets compounded, but compound interest I want to start on Monday. Okay, I'll explain this to you in very detail on Monday because 2 days gap we will have. Um, 2 days gap we will have this week, like Friday, Saturday. You'll forget it. Okay, you may forget it. So I'll do it fresh on Monday. Today, tell me, did you understand how to calculate simple interest? Principal rate time into 100, divide by 100. Okay, understood the formula? Understood the formula? Please write down the simple interest portion. Write down the simple interest part. Okay, it uses three things: the principal, the rate, and the time. The formula becomes principal into rate into time divided by 100. Please write this down.
Done, ma'am.
Done. Okay. Now, what we will do is we'll try out some questions. Okay, I'm clearing the screen. A person borrowed $1,200 from bank for a period of 2 years. At rate of interest 10% annually. Rate of interest 10% annually. Find interest. Okay, find the interest. Now, what things we have? What things we are having? We are having principal amount, which is 1,200. Rate 10%. Time 2 years. What is the formula? Our formula is SI, that is simple interest, equals to principal into rate into time upon 100. Use the formula. Write down the principal 1,200 multiplied by rather the rate 10 multiplied by time 2 and divided by 100. Find out the interest and tell me.
Is the interest 24?
24
Yes, ma'am.
240, Abraham.
Yes, ma'am.
Solve it, Joshua and Emma, you'll also solve it and find out the interest.
What, ma'am?
Solve
Okay.
it. Yeah, solve this and find out the interest.
Okay, ma'am.
The first thing that I told you on, they were
Ma'am,
cancelling.
I got the answer, I think.
Okay, Emma.
Ma'am, can I say it?
Yes, Emma.
240.
Yes, Emma, 240, correct. Okay. Now, Joshua, did you get the answer?
Yes.
We cancel out the zeros first. Okay, with the 0, 0, 0, 0 and 0. 12 multiplied by 2, 24. And 1 0 of 10 we have, so put a 0. Rupees 240 is your answer. Okay. Now, we will see how to calculate principal also, how to calculate rate also, how to calculate time also when you have the interest. Okay. When you have the rest of the things given and you have the interest also which is given. Yes.
Can I just go for one moment? The tablet is about to die.
Yes, Joshua. Go and come back quickly. Okay. I have to calculate interest for a period of 219 days on a sum of 1800 at 6% rate of interest. Also, I have to find the amount. Now, look very carefully. I am given the time period. Okay, this 1800 is my principal rate is 6%. If you take a look at the time period, it is not in years, it is in days. It is 219 days. Okay, not 1 year, 2 year, 3 year. If it is 1 year, 2 year, 3 year, we can directly multiply. We can directly multiply, but this is in days. So first we convert the days into year or what portion of the year it is. Okay, how to do that? We'll do time equals to time equals to 219 days, okay, equals to divide 219 by 365, okay, 219 by 365. This will give you how much of the year are we finding out the interest for, okay, how much of the year are we finding out the interest? It will come to 3 by 5 here. Now 3 by 5 is your yearly or like part of the year time. Okay. This 3 by 5 you have to use. Please don't do 219 into 1800 into 6. Please don't do that. Okay. First
Ma'am,
divide. Yes, Abraham.
ma'am, I was trying to do three, I was trying to do 1800 upon into 6% upon 1800 in upon 100 into 365.
Abraham, your voice broke totally, so I couldn't hear it.
Ma'am, I was trying to do 1800 upon 6 up into 219 upon 100 into 365.
Correct, Abraham. That is also correct. Okay. That is also correct if you do it directly. Okay. Or if you break it down first and then do it, both are correct. Okay. Now put it in the formula. Simple interest equals to P into R into T upon 100. How much principal? Principal is my 1800 multiplied by 6 multiplied by 3 divided by 100 into 5. Okay, cancel the zeros. Multiply and find out the answer and tell me. Multiply and find the answer. And tell me the simple interest. Oh,
Ma'am, I'm getting 30.40.
30.40, Abraham. I want you to recheck it. Recheck it.
Ma'am,
Abraham.
32.4. 32.4.
No. Are you getting 324 divided by 5 first?
Ma'am, can you just repeat?
You're getting 324 divided by 5.
No, ma'am.
Then mistake is there, Abraham.
Yes, ma'am, I'm getting 324.
Yes, now divide and see.
Ma'am, 64.8.
Correct, Abraham. 64.8 or 64.80. Now find out the amount. Yesterday I taught you how to find out the amount. Who's going to tell me the amount formula?
Amount plus principal plus interest.
Amount is equals to principal plus interest. Plus interest. Joshua, find out the amount and tell me how much will be the amount. Add principal and add interest and find out the amount and tell me.
Ma'am, the bottom one is the principal.
Say again.
Is the bottom nothing, ma'am. Thank you, ma'am.
Tell me what is the amount. What will be the amount? Do it and tell me.
Now I've got the answer.
Ma'am,
Yes. Joshua?
6,519.
6,000.
519. I added up the principal and interest.
What is the principal, Joshua?
Principal is 3 by 5.
Principal is 3 by 5.
I mean, 6 and 4 by 40. I mean,
How much?
6, 4 by 0.80.
No, that is not the principal, Joshua. Look again and tell me what is the principal. Look at the question and tell me what is the principal.
324 by 2.
Yeah.
Ma'am, can I help Joshua?
1 minute, Abraham. $1,800 is your principal. Okay. Why? For a period of 219 days on a sum of 1,800. When you've given a sum of this, that thing in your question is your principal. Okay, that big number that is there is your principal. You will have a time period like days or years. You will have a rate which will be in percent, and you'll be given a big number in rupees. That number is your principal. 1,800 is your principal. Now tell me what is your interest? What is your interest, Joshua? Unmute and say.
The principal and the interest, I first add them up, ma'am.
Yeah, you add them up, but what is the interest? What is the interest? What is the interest, Joshua? Principal is 1,800. What is the interest?
6% interest.
How much? 6%. Then what is rate?
Pardon, ma'am?
Tell me what is interest? What is interest? Okay. This is interest, Joshua. We just calculated interest, okay? This formula that I used, this SI means interest. This formula that I used to calculate was interest formula. And this is my interest. This is my interest. Okay. Now find out the amount and tell me. Principal is 1,800, interest is 64.80. Find out the amount and tell me how much will be the amount.
Ma'am, I added them up. I got 4,680.
You got 4,680.
Yes, ma'am. Ma'am, when you said add, I did addition, ma'am.
One,
Because
8,
you said, ma'am.
0, 0, plus 0, 8, 4, and 6. Okay, put a point here. Add 0 plus 0, 0. 0 plus 8, 8. Point 8 plus 4, 9, 10, 11, 12. 2 carry 1. 6 plus 1, 7 plus 1, 8.
Ma'am, I had forgotten to add the point.
Um, 1800.
Ma'am,
1 second,
ma'am,
Abraham. Yeah.
ma'am, you did something wrong.
I did something
The,
wrong.
the 64 should be where the zeros are. The answer you should get is 1864.8 because there's a point.
Yeah, I think I did something wrong. You can directly add 64 to 1800. Okay. First, add 64 to 1800. You will get 1864. Okay. And then you add the point separately. Okay. You add the point separately, put the decimal behind it. 80. Okay. 1864.80. I think I just
Ma'am,
added up. Yes.
ma'am, another way to do it, ma'am, is you can write 1800.00 because you can put how many ever
Yeah.
zeros. It makes it more simpler to understand.
Yes, Abraham. That's what I missed here. Joshua, you can do this also. Okay. You can do this also. I forgot adding 0.00 to 1800. Can directly put the decimal. Okay. 1864.80 it will become. Your answer will become 1864.80. Understood now? Okay. One more question we will see. Rutan, all of you? Okay.
Yes,
One
ma'am.
more question. Okay. One more question we will see. We saw how to calculate the interest. Okay. Next, we'll check out how do we calculate the principal, how we calculate the rate, and how we calculate the time. We'll be learning all three of them. Okay. Calculation of principal for rate and for time. This is finding out the principal. How much amount should I deposit? Deposit in a bank so that after 2 years at a rate of 8%, after 2 years at a rate of 8%, I should get rupees 128 as interest. Here you have time, 2 years, rate 8%, interest is rupees 128. You have to find out the principal. You have to find out the principal. Now, we use the same formula to find the principal. Okay, we use the same formula, but we change the places. Okay, we change the places. See, formula is SI equals to P into R into T upon 100. But we know the SI. SI is 128. Write 128 equals to principal is how much? I don't know. So P into rate is 8 into time is 2 divided by 100. Okay. Now I take when we have to find the value of a variable, P is a variable or a missing value, we take it to the other side. We take it to the other side and we take the numbers together. So this P I will take here and this 128 I will take this side. Okay, 128 I will take this side. 128 here, when it will come here, it will reciprocal will happen. Okay, reciprocal will happen because we change its operation also. We change its operation also. Okay, multiplication becomes division, plus becomes minus. So reciprocal happens and it becomes P is equals to 100 into 128 divided by 8 into 2. Okay, 8 into 2. Now you can cancel and find out the answer. Find out the answer and tell me. 100 into 128 divided by 8 into 2. 2 ones are 2, 2 6 are 12 and 4s are 8. 8 ones are 8, 8 8s are 64. Okay, P is equals to 100 into 8. Principal is equals to rupees 800. Okay, rupees 800. Understood?
Yes, ma'am.
Joshua, understood?
Yes, ma'am.
Write this down, please.
Yes, ma'am.
Ma'am, the formula or everything?
Everything.
Okay, ma'am. Done, ma'am.
Done. Okay. Monday, we will see how to calculate time when we have principal, rate, interest given, and how to calculate rate when we have principal, time, and interest given. Okay, that we will see tomorrow, Monday. Okay, Friday, Joshua, Friday, this Friday, coming Friday, we have a quiz on the chapter of percentage. Okay, we have a quiz on the chapter of percentage. So please prepare percentage chapter this Friday. Okay, we'll do quiz this Friday on percentage chapter. So please prepare. I will I can tell you also, like I'll go through it. Okay, and I'll see if I can like tell you what topics the quiz will be from or what exercise the quiz will be from. Okay, either the full chapter or some particular exercises. I'll let you all know. Please prepare for
Okay.
Friday quiz on percentage. Okay, and please try out some questions. I'll give you all some questions to try out from what we practiced today. Okay. Okay, then that's all for today.
Ma'am,
Bye,
Yes,
ma'am. Thank you, ma'am.
ma'am,
yes.
Monday is doubt class.
Doubt class. You had doubt, right? Okay, I'll take doubt on Monday. Okay, I'll take your doubt on Monday.
Ma'am, you sent us the 10th math test.
Which test, Abraham?
The math one for
The
chapter
math one.
6.
6. I'll send it, Abraham. Okay. By this weekend, I'll check and I'll send you.
Bye,
Okay, then.
ma'am.
Bye. See you all.
Bye, ma'am. Thank you, ma'am.